Okay, so good afternoon to you all. My name is Lazar, and I'm here from Brno University of Technology, Faculty of Mechanical Engineering. And on the faculty, we have several space project, space-related project. With the 15 institutes on the faculty, I just highlighted some of the most prominent institutes that we cover in order um, to attend some of these space projects. We are able to provide material testing, vibration testing, additive manufacturing, and also mission development and structure spacecraft designs. Today I'm going to speak about our Institute of Aerospace Engineering in more detail. So we have three basic working groups on our institute. I'm going to talk about the space technology group. Within the space technology group, we nowadays focus mostly on CubeSats, drone technologies, and large structure systems. But we also cover some of the design, testing, analysis, and integration activities as well. As an institute, we are part of the industrial cooperation and also national and international programs. And most recently, also the Brno cluster cooperation. Just to highlight some of the space projects that we have on our institute, those gray ones are the past, and right now we have several ongoing space projects. I'm going to talk about some of them in more detail right now. So one of the first projects related to the space technology that we had was a SPARTAN. It was a project that tested a module that was supposed to test hybrid engines and to perform a soft landing on Mars soil. So as an institute, we were responsible for the testing, for the fire testing, and also for the integration and manufacture of this test bed. Yeah, another recently successfully enclosed project was additive design for aerospace application capabilities. And here we closely work with the others institutes as well on a 3D print or additive manufacturing from metal parts. And you can notice some of the exotic structures right here that we tried to print. We measured, for example, the porosity and thermal conductance of such a part. The estimated technology readiness level was 3 at the end of the project, so we hope that we moved the technology far further. Now, one of the ongoing project is heat switch development. You might find heat switches, for example, as a passive thermal regulation units on ExoMars, on Mars landers, and some of the big spacecrafts. We are as a prime contractor of the ESA on this project, so we are responsible for the development and testing of the equipment. The equipment you can see here. This is the breadboard that we test right now in our thermal vacuum chamber that is quite small because it was built on purposes of this project. Yeah, another quite interesting project is Moon Drone. This is a project where we design and test the vehicle that is supposed to autonomously move on the Mars surface, on the Moon surface, in order to explore the area. And as an institute, we are responsible for the design of the main structure, so the metal part there, and also the test bed and the assistance during the fire testing and other activities. One of the most recent projects is our CubeSat development project, which is part of the PhD students' competitions. that was supported within the university program. The goal of the project is to develop an engineering model of one new CubeSat, of the very first CubeSat of Brno University technology as a whole. So part of the project is also the mission proposal and additive manufacturing possibilities research within this field. So as a mission, we purpose a small satellite mission. The goal of the mission is a corona observation with a small satellite located on a LEO orbit. We utilize the moon as an ocular in order to reduce the diffraction on the shade. And in this way, we can actually observe the area that remains blind, for example, for another space-based coronagraphs. So we would get closer to the surface of the sun in order to observe the white light there. As you might notice, the mission is heavily based on the orbit that we found. So for this purpose, we also calculated some of the orbits from year 2024 till 2030. And so we got the two kinds of results. The first one can be a unique observation, as we call it. This is the opportunity to observe the solar eclipse in a white light close surface region, while there is no possibility to observe, to gather such data from the ground-based observation. This is the example of 2025. But also we can observe the eclipse or the corona during the year that is going to have a total eclipse on the ground, and we can compare the data and study the dynamic effects within the corona. And to conclude my presentation, I would like to say that the purpose mission is a science mission, as we call it, is a solar system exploration mission with some of the fields of the space technology development as well. And since we cover some of the areas within our university, we are still open for any potential partners, for example, for secondary payload on assumed 6U small sat that would perform the mission. So in case you are interested, feel free to approach me anytime, and thank you for a presentation. Or
So
attention, of course, yeah.
Are there any questions?
Sorry, I did not catch it. I would like to understand. I mean, the reason for all these studies you mentioned is to make this observation. What is the goal? I mean, one thing is measurement, but what is the goal? I mean, to measure. What is the final output of this measurement? Thank you.
So during the total solar eclipse, that is an event on ground that we can observe, you can get data that is very close to the surface of the sun. But you cannot observe such a radiuses from a space because of the coronagraphs construction.
Yes, this I understand, but I would expect, but please correct me, is that you are taking the data, but then you are collaborating with someone who is analyzing this data, because this is unique opportunity how to come close to the surface of the sun. That's what you're saying, correct?
Yeah, we plan to integrate an optical instrument within the CubeSat to gather the data and to process the data based on a method developed by Professor Druckmiller.
Okay, and the final goal is to achieve agreement with a solar model. I mean, to understand whether the model of the sun is correct, but is it your task or you are? I mean, that's what I'm asking about.
So we are aiming to provide those data. And because the closed surface area is very interesting for dynamics effect for small structures, and so we would document these.
And the data will go to who?
To Professor Druckmiller of Miloš Druckmiller.
Thank you.
From the University of Technology. Yeah. So he's also involved in this project.
Are there any other questions? If not, thank you very much.